Guys, welcome to another problem. This is problem number 45, jump game 2. And what this problem states is that given an array of numbers from any particular index, the max index that you can move is the value at that index. And the mean index that you can move is just the index immediate to it. So what that means is that if we are at index 1, then we can max move 3 steps from this index or a minimum of 1 step from this index. So the number of moves that we can have at this index is 3. That is 3, or either we take 3 steps or we take 2 steps or we take 1 step. Similarly, for this index, we can take either 1 step or we can take 2 steps. So now that we know how to move between the indexes, what this problem asks is, given such an array and starting at index 1, what is the minimum number of steps that we can take to reach to the last index of this array? So let's see, if we are going to start at position 2, we can either move to this index or we can move to this index, right? Let's start by moving to this index. In that case, we only have a choice of moving to the index next to it because the value is only 1. And from this index, we only have a choice of index moving to the next index, and finally we reach to the end of that array. So the number of steps that we took was 1, 2, and 3. But if we choose to move to the index immediate to it, that is from 2 if we move to 3, so we have the maximum 3 steps from this position because the value is 3. So if we take the maximum step, we would be able to reach to the end of that array. So the minimum number of steps that we can take to move to the end of that array would be 2. Great. Now we understand that problem. Now let's go into thinking how we can solve this particular problem. So we had that array of 2, 3, 1, 1, and 4. Now, what is the decision that we can take from any particular position, right? So if we are at the value 2, which is at index 0, we can either move to the index 2 plus 1, or we can take 2 plus 2 steps, right? We can either take 1 step or we can take 2 steps. So if we are going to take 1 step from index 0, then our value is 0 plus 1. Oh, we can even write it like this. At position 0, we have 2, and since we have 2 at 0 position, we can either take 0 plus 1 step, that is 1, or we can take 0 plus 2 step, that is 2. So we will either end up at the first index or at index 2. So either we will be here or here. If we are here, that is we encounter 3, then we can either take 1, because the index over here is 1, plus 1 step, or 1 plus 2 step, or 1 plus 3 step, right? So for every decision that we are arriving, the value at that index, we are going to add that value of that index to the index where this value is present, and that is the maximum step that we can take, and the minimum is 1, right? So we can create a depth first search for this and keep searching the different ways we can reach to that end of that array. Now there is one thing to consider, that is, if we are moving from 2 to 3, and similarly from 3 we are choosing to move to 1, because 1 is also a possibility, or we can move directly 2 steps over here. So the calculation for the number of moves that we can take if we were at this index, we would we might need to cache that thing such that we don't end up recalculating, right? For example, for 2 we will check both the ways we can move, right? If we are choosing to move 1 step, we are going to 3, and from 3, if we are choosing to move to 1 step, we would be arriving here. Similarly, next time when we choose the next option to move 2 steps from here, we would again end up at the same location. So again, recalculating this path is redundant, right? We have to, like, that is already pre-calculated when we try to move to 3 and from 3 to 1. So every time a operation happens, I mean, it is clearly that we can cache that thing, and if we are going to cache a particular minimum number of steps that can be taken to reach to the end of that array for a particular index, so that is nothing but a DP memoization problem. Now, how we would solve this is, first we will build a depth first search recursive method and try to implement a memoization technique on top of that, so that we get a clear understanding of this problem. Now, let's jump into creating a solution for this problem. So, let's create a function, and in that function there is an index. Now, how for every index, how many steps we are able, what is the max step that we can take, right? So what is the max number of jumps or steps that we can take? So the range is the value at that particular index plus the value of that index, so that is the maximum jump, or the minimum jump is the value, the minimum is the index plus 1, sorry, and we are going to, so this is the maximum and the minimum, right? So what was the maximum? What is the, whatever the value is at that index plus whatever index that we are in, that we already established over here, right? The maximum is for index 0, the maximum is 2. So the value plus the index that is present, and the minimum is whatever that value, just one step ahead of that value. So since we are using a range function, so if we are going to use the index, since the index was 0, just if we are going to use, I mean, the second part is 0, so it will just be the step before the 0, right? I hope I'm like able to comprehend that. And now what we are going to do is, now what is the base condition that we are going to establish, right? So if we are going to go for a depth first search, so every next step or the next index that we are going to get, it's the number of moves that we have to take to reach to that end of that array is dfs of j, and the present, and we have to add just 1 to that, and we get the total number of moves, right? For example, from here, from this point, the number of moves is 2, 1 and 2. So if we are choosing to move to this one, this is one step, right? So how many, if we are taking 2 steps from 2, how many moves do we need to reach to the last index, right? So it is already 2 steps from here plus 1 step to move to this step. So that is what I'm adding, 1 step to move to that whatever step that we are taking to move to that index, and whatever the minimum number of steps that is present over in this index, we just add 1 to that because we have to move to that index, right? So we can get a minimum of let's say what can we say, steps, I will say minimum moves, let's call this minimum moves. And minimum moves needs to have a value, and we can just say minimum moves is this, right? So whatever the value of the minimum moves at, I mean, since we are going to calculate the minimum moves, whatever the minimum number of moves that was present at this step, we just add 1 to go to that step, and we compared that to I mean, every time we are generating a new step, we are just comparing between all the different minimum moves for every kind of step, right? And we are finally getting the lowest minimum move, and we just return the minimum moves, right? And the initial value of minimum moves could be a maximum value, and I would choose to have a system dot max size. Alright, now let's establish our base condition, that is when can I say that I have reached to that end of that array, right? So if index is let's say greater than or equal to the length of that array, if index, let's say for example, consider an array like this, 2 3 and 1, right? So at this index we can take a maximum of 3 steps, but 3 steps is out of the bound, right? So whatever number we are going to generate, I mean, if that value of that number is greater than if it has exceeded the length of that array, or it has reached to that end of that array, do we need to take any more steps to reach any further to find the length of that array? No, right? So there are no steps needed. So to sum it up, what happens is that if the next step, let's assume just taking the next step from this particular index that we are at, is going to achieve the going to achieve our objective of reaching the end of that array, in that case it is going to return 0, right? So it is just the one step that we need to take to reach to that end step, and that is the index of that array. So I mean, hope I'm clear on that. I mean, let's assume that array is something like let's say this is 1 and 0. So from 1 to reach to 0, that is one step, right? So here is the one step, and once we have reached to that step of 0, I mean, there is no need of it to move any further. So we are just returning the base of 0, right? So this would be our depth first search, and if we can check against it, uh, depth first search of 0, so it passes both the cases that are present, right? So we have completely established our condition. Now there is one thing, because this loop is getting generated from the next index to the max, or the maximum step or the maximum jump that we can take. If for example that value at that index is 0, let's assume that particular index where we ended up, the value is 0, right? So in that case, this loop would not even run, because wherever that index is, I mean, let's assume the index is 0. From 0 to 0, I mean, that loop is not going to run. So if it encounters 0 at any moment of time, it won't be able to proceed any further, and that is our objective, right? So it is going to take steps after steps to till the time it is going to reach to the end of that array. But if we are going to run this solution, I mean, it is going to give us time limit exceeded error. So how we can modify this solution to make it better is that we have to now introduce our memoization technique, right? So what we are going to do for memoization, I mean, let it run. I mean, we have already understood that this is going to give a timeout. So we are going to now do this. Whatever array that we are presented with, right? let the value at this position is phi. Now let's assume phi can be a 3 step or 2 step or 1 step. Now, if we already could pre-calculate the values at these steps, then we would not need to recheck every time, right? For example, the situation that we encountered over here, if 2 is going to take 1 step to 3, and then from 3 if it is going to take 1 step, similarly from 2 if we are going to end up taking 2 step, in both the cases we are going to encounter doing the same operation twice. So every time what we can do is we can pre-calculate the values for every of these positions, and every time we find the number of different steps that we can take, all we have to do is choose the minimum of these three values, and that is the minimum number of steps that we can take from v, and keep update v with that step. Next, go to this step and do the similar kind of operation, right? So we can uh, create, I mean, as expected, it create a time limit error. So we can create a TP of cache. So we can create something like a TP, and the keys in this DP would be the positions of the array, and whatever minimum number of steps that position can take would be the value, right? And now, what is the minimum number of steps that is required to move to the end of that array is 0, right? For this position, for this position it is always 0, because if we are at this position there is no need to take them anymore for the steps. So the what is the minimum value that we can take if we are at the end of that array? 0, right? Now for every other positions we have to now calculate based on this, and what we can do is calculate that for all the lengths, for all the positions of that array, -2, because we have already calculated for -1, right? So we are now going to calculate for -2, and fill every other positions of that array, and what we are going to return here is dp of 0 position, because we are going to take the minimum number of steps starting from the 0th index, right? So now what we are going to do is dp of this index is nothing but, since our DFS function is working, so that is all. Every time we calculate the last step, we have to always start from the last step. We calculate this based on this, and then we move to this, and every time we call this DFS function to fill up this dp. And what we have to do is here, if index is in dp, then all we have to do is return dp of index, right? Cool. Now let's check this code once more. It is perfectly working. Now let's submit. Cool. And there we have a submission, though it is not a pretty good solution, but the reason I did it in this way is because this will clear a lot of memorization techniques around depth first search, and how we can move from depth first search into building a DP solution. So that's it for today. Thanks a lot.